So, two things to remember when using long division is you have to make sure that everything is in standard form, so that's important, and that any term that is missing in standard form, you want to make sure that you have kind of like a placeholder for it, have a zero coefficient in its place. I'll show you what I mean by that, by this part here. I'll show you what that looks like when we do example 1. Okay, then you're going to write the division the same way you would when dividing numbers. So let's walk through example 1 together, which is going to be on the next slide to give us some space. So starting off, you'll notice that in example 1, we have negative y squared plus 2y cubed plus 25. This is our dividend. We need to write this in standard form and then insert a 0 for any of our missing terms we might be having. Our highest degreed exponent in this problem is the 2x cubed, and it's positive, so I'm going to write it first. Then I have minus y squared. I don't have a y term though. So what I'm going to do instead is I'm going to add in a 0y as kind of a placeholder of where the y term would be if we had one. And I write a 0 there because 0 times y is just 0. So I know that there's no y term, but I need to represent its place of where it would be located by writing in a 0. It's really going to make a difference when we go through this division process to make sure that we're subtracting terms correctly. Then after that, we have plus 25. So this in standard form would be 2y cubed minus y squared plus 0y plus 25. So setting up my problem now, y minus 3 is my divisor. My dividend is the 2y cubed minus y squared plus 0y plus 25. Now let's start this process of long division. I have to think, I'm just switching to a highlighter, sorry. This first term in my divisor, y, needs to be multiplied by something that I'm going to write up here in my quotient that's going to give me 2y cubed. So if I were to write this question out at hand to kind of show you my thinking process, y times some number needs to give me 2y cubed. So I got to figure out the answer to this question. Y times what is going to give me 2y cubed? And the answer to that question is 2y squared. And I can check my work, right? If I were to replace this question mark I wrote over here with 2y squared, does it work? Y times 2y squared, does that give me 2y cubed? Yes, it does. So I know that 2y squared is going to be the first part of my quotient. All right, I'm going to erase this off to the side because I'm going to show you more of my thought process and I don't want to run out of space. So now that we've answered that first part where I have the piece in my quotient, the 2y squared, now I need to take that and distribute it in to both pieces in the divisor, the y and the negative 3. So 2y squared times y is 2y cubed. 2y squared times negative 3 is minus 6y squared. I'm going to wrap that in parentheses and stick the subtraction sign on the outside of it. So now I'm going to take 2y cubed minus 2y cubed and subtract those. And I wrote this a little bit big, so I have to resize it real quick. Give me just a moment. There we go. The 2y cubes cancel out, it's just 0. Then I have negative y squared minus a negative 6y squared. There's that double negative there with that minus 6, which really means I'm adding a 6y squared. So negative y squared minus the negative 6y, that's going to give me a positive 5y squared. Then I'm going to carry down my next term. Now this process that I had started before is going to go on repeat. Now I'm back to the drawing board and I'm thinking about this y value in my divisor times what is going to give me this 5y squared. Y times what is going to give me 5y squared? And the answer to that is 5y. So now when I take 5y and I multiply it by this first y, I get a positive 5y squared. 5y times negative 3 is minus 15y. Wrapping that in parentheses and putting a subtraction sign on the outside. 5y squared minus 5y squared cancels out. So I know I did it right because that first term in this subtraction piece is canceling out, which is good. If it doesn't cancel out, you did something wrong and you need to go back and look at your work. Now this is also why we inserted that 0, because now I have 0y minus a negative 15. That double negative becomes a positive, so now I'm left with 15y. And then I carry down my last number of 25. Going through this process again, because we're not done yet, we can keep going. And you might be wondering, how do we know when we're done? I'll show you. Going through that process again, y, the first term in our divisor, times what is going to give us 15y. So y, the first term in our divisor, times what is going to give us 15y. The answer to that question is 15. So now I take that 15, multiply it by y, and then take that 15 and multiply it by negative 3. And I get 15y minus 45. Again, wrap it in parentheses and put that subtraction sign around it. The 15y's cancel. Then I have 25 minus negative 45, which gives me 70. Now I'm done and I can write my final answer. The reason why I know I'm done is because y, this y here, cannot go into 70. 70 doesn't have a y variable attached to it, so there's nothing I can do. So I've done as much dividing as I possibly can. So now, writing the final answer, I'm going to end up with 2y squared plus 5y plus 15 plus my remainder, which is 70, divided by the divisor of y minus 3. This is probably one of the longest ones we're going to be doing today. So this is lengthy, hence the name long division, but the cycle goes on repeat for every step of the way. All right, I want you to give example 2 a try on your own, then press play to see the answer.